Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, now we will learn about the moment. What is the moment? Actually, when we previously we learned about the force of two-dimensional body, and then we will know that the body have a tendency to move by following its application when they are applied a force on its rigid body. But actually, when the body has a tendency to move by following the direction of application, at the same time, a force also tends to rotate the body about an axis. So they have a tendency to rotate. And then this rotational tendency is known as a moment. And that is the moment. And the familiar example for us about this concept, please consider, and we will be very familiar with this example. If you have the pipe wrench, we have the pipe wrench and we have the force here with the direction. It's also the direction. Please give the attention to the direction because it's very important for us to know the sense of our force, of our resultant and others. And also we have the distance here. So two component here is force and distance. And actually movement also we can say there is a torque because they tend to rotate. So the basic equation for the moment about a point, so if they we can say there is the point O and have the force, it is the distance, so we can say that the m, it will be the f t is the basic equation for this. In two-dimensional drawing we can draw it like this. One is the pipe, the wrench pipe, and then you have the force here. And what about in the previously you have the distance here, so it's a perpendicular. It's a perpendicular. So the direction of the m, it will be depend on the direction of f when it's tend to rotate the body. So it depends on the direction of f, and the m equal to f d. It is will be important to determine which is the clockwise or counterclockwise. So you have to determine this to know the sense of the moment. And then the positive and negative signs is the convention to know only the sense of the moment. Now if we have the condition like this one, we can use what we call it as the cross product. By using the cross product, we have the new equation here by integrating the previous equation. So in the previous equation we only have the f times d, and the f is perpendicular. Here it is the perpendicular with the a from with the distance from point A. But we can also integrate this one by using the cross product, so it will be m, the basic equation is r times f, where r here, no, r here, here it is, r is the position factor which runs from the moment reference point, which is here is a, to any point on the line of action f. So if f has this line of action, the running point from a to f, it is the r. So what the consequences of this? The consequences of this, we will have the new component here, that is the alpha. We will have the angle here. So by using the cross product, we will write this, that the f will be r sin alpha. Why r sin alpha? Please remember that we have this one, we have two perpendicular. So if you want to write this one and make it to be the perpendicular, so we have to make it to be projected to like to this one, and it will be the sine alpha. So you have the final equation for the cross product is m equal to f or sinus alpha, and it will be equal to f times d. Okay, and then we come to the most important theorem in a moment, that is what we call as Variance Theorems, where the Variance Theorems states that the moment of a force but any point is equal to the sum of the moments of the components of the force about the same point. So here, if we have two force here, actually we have two force here is a P and Q. The resultant of this one, the combination of these two forces is the R. In this R, the small r here, it is the distance from the R resultant to the point of moment. So by using this one, we will have the equation like this one. At the point O, it will be R times resultant, where we know that the R comes to the P plus Q. So by using the distributive law, we can write this one as R times P plus Q. So it will be R times P plus R times Q. And this is the first. And then what if we want to make it to be the perpendicular like this one? This is the first figure and this is the second figure. So if we want to make this like this one, we can make it to be the M at the O point. It will be R times D, right? Where the R is the resultant of P and Q, I mean, and sorry, that is the meaning moment R about the O here equal to the sum of the moment of O to the component of P and Q, because it's the vector component. Remember in the previous video when we learned about the force of two-dimensional systems, and here we will have the negative P times P plus Q times Q. And remember that it is because y is minus it is a plus because it's the convention of the direction of each forces. And here it will be, so M O here it will be positive for the Q here. See the Q here, this is Q here, it will be clockwise. And there is the Variance theorem. So you can not only is maybe very easy for two moments, but it's also very impactful and not restricted to case of two components only, but it can be applied well to 3 or more forces. So it's really very powerful. This is the first example of the moment. I have a force of F of magnitude 60 Newton is applied to the gear. Determine the moment of F by the point O. So we have the F here. The F with the direction is the direction of this F, and F, the magnitude of this one is 60 Newton. And what about the R? R is 100 meters. It means that the distance from the point O to the F is 100 millimeters, but I want to convert this one to the SI unit, so the millimeters, 100 millimeters, it will be 0.1 meters. And then I will solve this one by using this equation. So M R cross F. Okay, I have finished this one. And then we have the R cross F. Is the F and the F here, they have the angle by the 20 degree, where we have to project this one to the y direction. So if I want to make this one is the x direction, is the y direction, so I write this one is the R cross Fy. Why we only use the Fy? Why we don't use it or plus this one by using the Fx? Because if you see this one, if the Fx, if we projected this one to the side, so they won't have any distance. In the x direction, they don't have any distance here, so it will be times 0. The result will be 0. So we don't need to calculate the Fx in this example, but we have to calculate the Fy here. And 0, 1 is come from the conversion, and the 60 the F, and cos 20 we have, because we have to make the direction of F in the y direction, so it will be the cos 20 degree, and it will be 5,638 Newton meters. So now we are coming to the second example. Calculate the moment of the 250 Newton force on the handle of the monkey wrench about the center of the bolt. So we have the monkey wrench here, and it is the bolt. The force was coming here. Maybe the force will come from our hand, from the human hand, and they create the angle is about a 15 degree. And the distance here is 200 millimeters. So 200 millimeters. So previously we have to convert this one to be 0,2 meters, because we want to make it as a unit to be the Newton meter. And then what we have to calculate first, we have to calculate the MO, right? So MO will be okay. So it is the MO here. What is the moment at the bolt, where the bolt, the center of the bolt here is the point O. So we like say is the MO. The MO will be 250 because it is the force, cosine 15, because we want to project this one to the y direction. Okay, maybe I forget to make here this one is the y and x direction. So we have to project this one to the y direction. It will be the cos 15, and after we have this one, it's projected to the Fy, and the distance from Fy to the center of the ball is 200. So it will be time to 0,2 I mean, sorry. And then for the x direction, so it is the Fy and it's the Fx. Why we use the Fx here now? Because the Fx has the distance. So from here, if we projected the F to the x direction, they will have a distance. The distance is about 0,03. It is the distance. So we projected 250 Newton here times sine 15 degree and times 0,03. It will be resulted, or we will obtain 46,355 Newton meters. And so maybe this one, we have to know the sense of the movement. So the sense of the movement in this case, it will be the positive. It will be the clockwise here, because of why? Because of in this one, in the Fy, the Fy here is a positive, because it will be like this one for the Sy, and the Fx will be like this one. The Fy is higher than this, so it resulted the positive, and it showed that the Fy clockwise, it's not counterclockwise, and the fx is a counterclockwise. So the positive here means the clockwise. The sense of the moment, it will be clockwise, 40,355 Newton clockwise. And for the third example, we have the element of the lower arm are shown in the figure here in the below, and then the weight of the forearm is 5 pounds with mass center at G. Determine the combined moment about the elbow pivot 0 of the weight of the forearm in the sphere. What must be substantial force be so that the overall moment of the 0 is 0, but the 0, it will be 0 at the point O, I mean here. Okay, the first thing what we can do here is combining the resultant of a several force. Maybe if it's difficult to make the resultant of all of force here, or the resultant of the force of 8 force or the 5 force and the T here, we can calculate by combining two of this one first. So I choose to combine the 5 pound and 8 pounds weight first. Okay, by combining this 5 and 8 pound, we will have the M moment at the O, which will be like this. Okay, we have the 5 here because it is the F on the 5 pound, and the second one is the A pound. The 5 here, it will be the 5 times 6, the distance. The distance is the 6 here, and the sines, the 55 degree, is come from there because they have the angle here. So you have to calculate the angle here, the projection from this to this one. And then the 8 times 13, because in the normal direction, so we can directly multiply the 8 times 13, and we will get the 128,575 Newton. I'm sorry, here is the pound inch. And then what's next? The next is we can use the all of the resultant, because we have found the resultant of two force. We can use the resultant of all of force here, and then we will get the tension, because the most important thing here, we have to find how much the tension here, in order this arm can be at a steady state condition. So the T here will be found by using this equation. Now we can calculate this one by using the MO. So after we calculate by using the resultant of 3 force, we will have the combination of 2 force, and this one is the force of the third force here. It means the T, the distance the distance of this one to the point O. Here is the 2 inch, so it will be minus tension times 2 inch and plus the resultant of the force, 128,575, and then we calculate and divide by 2 is the minus, and then we will have the value here is the 64,2875 pound inch. So the tension of the forearm have to be 74, etc. And then what is the sense of this one? The sense of the first one here, it will be the clockwise. Why? Because this one is the clockwise, the clockwise, and we use the assumption here, the convention, the clockwise is a positive, and also in this one the clockwise is a positive, because the negative one here is the counterclockwise. We give the signs with the minus, so it will be the plus clockwise. So what about the magnitude and the direction of tension? The magnitude and the sense of the tension here will be the magnitude, it will be 74, and this one, and also the sense, it will be clockwise. That's all. Thank you for watching this video, and continue to watching the next video, because in the next video we will learn about the couple and resultant.